Hello and welcome back to STEAM with Steve. Today we're going to go through half adder and full adder circuits. So these are really important circuits that are sort of the cookie cutter questions that you get towards the end of this option test. So half adders allow you basically to add simple numbers, which are really basic ones, and then you can have a full adder that allows you to get the sum and then also the carry. So what you're seeing there is actually a full adder circuit. So a full adder is actually two half adders with an OR gate that matches and then allows you to add any number that you want, which we're going to unpackage how that sort of looks. So just bear with me as we jump into it. So what we're going to cover today is some basic Boolean algebra, so the not, and the or. We're then going to go through a half adder, and then we're going to go through the big dog, the full adder. So a half adder basically has two AND gates and an XOR gate with A and B, which is the inputs for the numbers, so either 1 or 0, and then allows you to have a sum and then a carry, which hopefully we'll see. So when we deal with not, basically the Boolean operation, not, we can either do a tilde at the front or we can put a hat or a bar over the top. There is a whole heap of different options. So when we did AND, we did the D gate. So A and B, basically there's only one time where the connections exist, and then that's when the whole thing turns on at the end. This operation wise, we should remember it was exactly the same as multiply. And then the AND symbol, like I said, was a D or a dot, like so. You then have the OR gate, which is the only time, which is the Star Trek logo, and the only time it doesn't work is if they're both off. And we can use the plus symbol to represent the connection between them. So it's very similar, except for the 1 plus 1 is equal to 10, but we just remember 1 plus 1 means that the thing's going to go on or plus. So the OR symbol, they use the plus symbol to represent. That's the way that Boolean algebra connects them. So what's more powerful in that expression, the times or the add? Well, hopefully you remember that the multiply always takes precedence over the add, okay? And it's the same when we're dealing with Boolean algebra. So the AND takes precedence over the OR when we're dealing with that. So always do the multiply before the add. So same when we do A and B or C, the AND gate takes precedence before the OR gate. So that's really important to know. So there's a little logically, open that link and build it. And what you should see when you play with it and create the truth table, if you turn them both off at the same time, C doesn't work, S doesn't work. If you turn one of them on, the C doesn't work, the S does. If you turn the A on, the C doesn't work, the S does. And then the 1 and the 1 then makes 10. So what you should see is that is literally adding numbers together. 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, and then 1 plus 1 equals 10. So that is what a half adder does. Now, if you want to add more complex numbers rather than 0 and 1, that's why we need a full adder, which then allows you to put things into series. So the way the half adder works is you need to put an AND gate to represent the carry, because that's what this column is. So 0, 0, 0, 1. And then the sum is the XOR for that pattern to work. So you can use logically, and hopefully you would have picked up that it would do 0 plus 0 equals 0, 1 plus 0 equals 1, 0 plus 1 equals 1, and then 1 plus 1 equals 10. And that's what a half adder is. There's a cool little video there that goes through it if you need a bit more support. So the light switch, when we did that for a full adder, basically looks like this. And what happens here is a little bit different. Is you have the ability to add in a carry, which gives you another column. So in this case here, if you have 0 plus 0 plus 0 plus 0, it gives you 0. If you add on 1 in the carry, it means that the sum gets one more. Same with this. This then becomes 10. Sorry, the S and the C should be swapped around so it's a bit more obvious. And then if you add all the numbers together, you get 11, because 1 plus 1 equals 3, which is what 11 is. So full adder looks something like that, which is pretty cool. So you need to be able to build both those circuits. So a full adder, when we look at it, basically has an XOR gate coming in from the A and the B. Then you have an AND gate that connects the output from the XOR into the AND gate. Then you have those going into an AND gate for the B and the C. And then they go into the OR, which represents the carry. And then the XOR at the end, which is pretty cool. So then there's the full adder. So XOR using not AND or OR gates is another possibility. So if you want to represent XOR gate without using the XOR gate, you can do it using this sort of technique. So if you do the NOT of A and B and A or B, that is exactly the same as A XOR B, which is kind of cool. So there's a HSC style question. The diagram shows half adder circuit. Draw the truth table of the circuit. Describe how the construction of the full adder by using two half adders. A diagram might help with your illustration. Describe the differences. Don't worry about the second part. So there's the answer. So there's the truth table for the first part. And then here's the half adder, full adder one that we just did before. So see how we use the half adder, and the sum from the half adder goes into the half adders as an input, and then the carry comes into that half adder, and then the output of the carry goes into the carry. So if there's a carry from here or a carry from here, that means there's going to be an extra one in the column, and then the sum is the sum of everything coming together. And then this is the description. The second half adder has the inputs of the carry in, the sum from the first half adder. An OR gate is used to combine the carry output from the first half adder and the carry output from the second half adder. The output of the OR gate is the final carry, and the other output from the second half adder is the sum. Define the term logic gate, so distinguish between a half adder and a full adder in terms of the different operations. Describe the operation of XOR logic gate and modify the following circuit. So there's the answers. So the logic gate is a piece of hardware that accepts the input of one or more bits, so high or low voltages, and outputs either a single bit. The half adder accepts 2 bits as an input using AND and OR, and an XOR gate like what we saw at the original, and adds them together, producing 2 outputs equivalent as the sum and the carry. The full adder then consists of 2 half adders and an extra OR gate that then merges together the carry part. So that you can also use XOR, it doesn't really matter, because it's only ever going to be those outputs. And then from the previous addition, the bits together produces the equivalent output as their sum and carry. Perform binary addition and then describe how the half adders and full adders would work in addition to the sums. So the half adder would input the 2 inputs and output a single sum and a simple bit carry. A full adder takes the 2 simple bit inputs and the simple bit carry in and outputs the simple bit coming through. The symbol below represents a half adder circuit, which will add the 2 bits together for the example using the symbol provided for the half adder and any other necessary logic. There we go. So you got number 1, number 2, and then you could also use a B exclusive OR with not A if you simplified that all the way down. So that's what the circuit did. Use the circuit for a 1-bit full adder for answer part C, I, and II. So this carry in, produce the truth table for the circuit using X, Y, and Z. Hopefully we should see by now the sum and the carry. So you got 0, 1, 10, 10, 1, 10, 1, 1, and then 11 at the end. So that's pretty much it. And then the purpose of the OR in the circuit allows for the carry from either of the half circuits. So this is basically if there's another, the next column across, that needs to be added in. So hopefully that's given you some quick insights into the half adder. They're very important, so you basically need to be able to replicate a half adder or a full adder on the diagram. The more you play with them, the easier it gets. My advice is to get into Logically and play around with them and see how they actually work by playing with the different circuits. So that's it from me. If you did enjoy this video, give us a like and subscribe down below, and please leave any comments if you do have any questions. Thanks again. See you next time on STEAM It with Steve. Adios.